boogie 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 boogie. The boogie 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 boogie. The boogie 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 boogie. See any phases in there you like? I kind of like this one because it's relatively correct, but you can have any phase you want if you know how to use an oscilloscope, even the correct one. Okay, so my supplier just happened to have some PG50s today, somehow or another, so we're running, I took out the bad one, and now we got number 6 there, so we got 5 IRF PG50s. There's the gang of 4 as Q2 with their non-color, oh no, these are color-coded leads. My goodness, how do you like that? All of the drains are green. All of the gates are smaller wires in bright colors. All of the sources are gray. So there's your color coding. And let's see, the little red twisted pair there, you can see function generator plus is the red lead, function generator minus is the black lead, and that little red twisted pair goes around and around over the hills and up the dales until it gets to the 555 module. Okay, and on the 555 module you can see that I've got the red lead clipped to the minus output, and then the plus output there goes through a 10 ohm resistor to the black lead. So the red and blacks are switched at the 555 timer. Okay, there's the 555's power supply hooked up to the mighty Ellen Co. precision power supply over there, pumping a whole 6 volts into it, 7 volts. And that's what's driving the tar baby, using this load here, 10.3 ohms, about 74 microhenries, including the leads, because I got my new Pros Kit inductance meter over there, finally came in, so I was able to measure the inductance of the load, and it's around 74 microhenries. And it's been running for a while, and the temperature is up to almost 90 degrees Fahrenheit here. Let's move that a little bit. And it's only about 70, and here I've got the air conditioning on. So we're heating the load. And over here we have the battery pack. There's 3 batteries. These are the same ones that I've been using for days and days and days. And the voltage is going down. And this is the indicated current on the ammeter, inline ammeter. I'm not claiming that this is the actual current, but it's consistent. Every time I have all the knobs and everything fiddly-twiddled and set just right, then this ammeter and this oscilloscope oscillation on the drain trace gives me 18. And I can go over here and I can tweak the power supply a little bit and make the oscillations get less or more, depending on how much power I put into the circuit loop, and I can make this get bigger and smaller and bigger and smaller, depending on how much amplitude is in the oscillations. So I don't really care if this is really indicating 170 milliamps yet. All I care is that it's a reproducible, accurate, precise figure, not necessarily accurate. Okay, but other indications have led me to believe that it is fairly accurate because it corresponds to the heating of the load. Alright, so anyhow, I don't know what the problem is. I've got the same waveforms, the same MOSFETs, the same, phase anywhere, phase here, phase there, you name it. I can make the phase go wherever you want. If you want phase, or if you want faulty trigger, I can do that. But if you use the oscilloscope correctly, then you get the correct phase relationship and the correct frequency relationship and all of that stuff. And the voltage is dropping. Now, sure, these are cheapo multimeters, so maybe my batteries are in fact not going down. maybe this is not the true voltage on the batteries. Maybe the oscillations in the circuit are confusing it somehow, and I really am heating the load without draining the batteries somehow. So when this meter here gets down to 30 volts, which should be maybe tomorrow morning at the rate things are going, the load will probably be up around 120 or 130 degrees F by then. Then when this is down to about 30 volts, then I'll know that the batteries have been discharged sufficiently to use them in the dim bulb test part 2. Oscillations. You tell me those are not the right oscillations? I think they are. Bye-bye.